Alrighty, good people. Today we are talking about applications of matrices, specifically using them to solve systems of equations. Now, there's all sorts of applications of matrices. There's a whole branch of mathematics called linear algebra, really devoted to matrices and all the things they can do. But right now, at this point in your math career, most useful thing to you is probably using it to solve systems. Okay? I probably wouldn't put these down in my notes yet, but maybe after we get a couple of examples in, maybe you want to use this language to identify what you were doing in each step to make those notes meaningful to you. So first thing we're going to do is write things in matrix form. We're going to take it out of the system. We'll have three different matrices: the coefficient matrix, variable matrix, and the constant matrix. We're going to find the inverse matrix. We talked about that previously. Then we're going to multiply by the inverse on each side. Now we know when we're multiplying, order is important. So on each side, we're going to put the inverse first, then write out the solutions. Alrighty, so solving the system using an inverse matrix. Step one, we're going to write in matrix form. So we have our coefficient matrix. Where we take those coefficients off. We'll have our variable matrix working with x and y here. And our constant matrix. Okay, next thing we need to do is find the inverse of this matrix right here. Okay, we've talked about the inverse before, starting with that determinant. Okay, so we multiply across one diagonal, 4 times 9 to get 36, minus what we get when we multiply across the other diagonal. Two negatives end up making that positive 40 there. Don't forget we're subtracting it. Okay, flip-flop here across the diagonal. 9 and 4 get flip-flopped. Then we change our signs here on that 8 and that 5. We can go ahead and tidy this up just a little bit. So 36 minus 40 in that denominator. We get 1 over negative 4. Okay, you've got a couple of options here. We have that negative 1/4 as that scalar out front. You can go ahead and multiply that into each element of the matrix if you would like, or you can leave it with that negative 1/4 out front. My personal preference, I look and see what would happen if I multiply it in. I would have some messy fractions to work with, not too bad. That 8 and that 4 would clean up nicely, but the 9 and the 5, not so much so. So my personal opinion on this would be leave it as that scalar out front. Okay, so just a little note to yourself here. You can leave it, or you can perform that scalar multiplication. Okay, so that is the inverse of our coefficient matrix. We're going to hold on to that. That's going to come useful here in our next step. Okay, so that step 3 is multiply by the inverse on each side, inverse first. Okay, so what we really need to do is undo that left-hand side. Okay, we know when we're solving for something, we got to undo. That inverse matrix is what allows us to do that undoing. Okay, so we're going to take that negative 1/4 times that matrix 9, 8, 5, 4, and multiply that on each side. So let's see, I'll switch gears here. It must come first, okay? Order is important when we're multiplying. So we have that inverse matrix. Times that coefficient matrix. So what I do to one side, I'm going to go ahead and do to the other. Keep things equivalent. That variable matrix equals, okay, remember that inverse matrix has to come first, multiplying this other side here. By that constant matrix. Okay, I've been saying this all along in our matrix unit, but there are so many places where we could make a silly mistake, okay? And these take a lot of work. So it is absolutely worth your time to pause real fast, go back, double check your signs, make sure things went where they were supposed to go before you proceed. Okay? Now we got some multiplying to do. Let's go ahead and take care of that multiplication on the left-hand side. We'll take care of that multiplication on the right-hand side. Now, I said we want to make sure we're checking our work. There's a nice little check that's about to come up that's going to tell me, okay, I at least did the inverse matrix part correct. Okay, because what I'm trying to do is undo. Okay, trying to get that x and y ultimately by themselves over here. Okay, so I'm going to leave that negative 1/4 out front. Again, you could have multiplied it in right here from the get-go. As we're about to see, then I'd be dealing with fractions for longer, your call, but my personal preference is to avoid that. Alrighty, rows by columns, rows by columns. Okay, so we have that 9 times the 4 to get 36. We're going to add to that 8 times negative 5 to get that negative 40. Okay, then I take that 9 times negative 8 to get negative 72. 8 times 9 to get positive 72. Okay, row by column. Now I'm on to the second row. 5 times 4 would give us 20. 4 times negative 5 would give us negative 20. Okay, 5 times negative 8 would give us negative 40. 4 times 9 would give us positive 36. If you're not remembering that stuff right there, I'm going to recommend you go back and watch the multiplying matrices video. Make sure you do know how to multiply your matrices together. Okay, rows by columns here. 9 times negative 4 would give me negative 36. 8 times 6 would give us 48. Okay, 5 times negative 4 would give us negative 20. 4 times 6 would give us 24. Okay, pause, double check your math before you go and clean it up. It is worth that time. You do not want to find out you made a mistake way down the road if you can avoid it. Okay, we start to clean this up. Again, I'm about to see my quick check on whether or not things have gone correctly so far. Okay, negative 4, 0, 0, negative 4. I'm liking that. That's a good sign, and I'll show you why. Okay, here, negative 36 plus 48, well, that would give us 12. Negative 20 plus 4 would give us positive 4. Okay, let's go ahead and take that scalar into each term now. And this is that left-hand side where this is going to tell me if things went well. Okay, negative 1/4 times negative 4 gives me positive 1. Anything times 0 is 0. Negative 1/4 times negative 4 would give me positive 1. That is a great sign, okay? What we call this right here is our identity matrix. What this means is that we properly undid the left-hand side, okay? What we have done essentially is get x and y by themselves equals, okay, over here I take that scalar multiplier into each of those. Negative 1/4 of 12 would be negative 3. Negative 1/4 of 4 would be negative 1. We just found x and y. Okay, your x value is negative 3. Your y value is negative 1. Okay, let's look at one more here. Okay, these are your notes. You might want to add any language if like remembering what step we're doing is important. I'll put those steps back up at the end of the video if you want to add those into your notes. Something that's going to help you say, okay, I see where I'm at and what I was doing in each of these steps. So the very first step is to take that system, take our coefficients, watch your signs. Then we have our variable matrix working with x and y here. We only do 2 variable equations here in Algebra 2. However, you could use this for even more variables. Adds a few more steps, but can be a great way to keep your work organized. There's also other ways to solve systems using matrices. This is using the inverse matrix, but there are other ways if you're curious to look into, see if you like those more. Alrighty, so double checking my signs. Yep, things are looking good. Okay, so first thing I need to do is find the inverse of our coefficient matrix. 1 over that determinant, so multiply across that diagonal, so I'm looking at negative 14. Subtract across my other diagonal, negative 6. Don't forget, we got to do a little flippity-doo-dah here. Flipping some places, flipping some signs. Okay, let's go ahead and tidy this up just a little bit more. We're looking at 1 over negative 8. Again, your call right here. You can take that scalar multiplier and multiply it into each element if you would like. You're going to work with fractions for longer then, if that's what you do. But that is fair game if that is something you are interested in. Okay, so we found the inverse of our coefficient matrix. It's time to do that multiplication piece. Now remember, the inverse must come first on each side. So we take that inverse. Now we're multiplying it here by what we started out with. Over here, inverse has to come first. Alrighty, take a moment, double check yourself, double check me. I don't want to accidentally lose this negative, so I might make it a little more prominent there. I believe things are looking good. I'll have that opportunity here to do a quick little gut check by knowing that I should find the identity matrix here when I do my multiplication. Oop, I said everything was good. This should be an 8. I was thinking of that last problem. Thank you if you were yelling at me through your computer screen. Alrighty. We don't want to lose that negative 1/8 out front. Okay, rows by columns, rows by columns. Can you do this in your head? Yes. If something goes wrong, it's a little bit harder to backtrack your work and make sure things clean up okay. Okay, took care of the first row. On to the second row now. Rows by columns, rows by columns. Okay, over here. Okay, quick check. I've got a good gut feeling about what's about to happen here on the left. Let's hope my signs shake out okay here. Okay, on the left-hand side, when I put that scalar into each of the elements, I want to end up with the identity matrix. If I don't, something went wrong, okay? I don't want to power through at that point. I want to backtrack and double check my work because it's going to throw everything off. Okay, what that tells me there is that I properly undid the left-hand side. And if everything went well on the right-hand side, I properly undid that one as well. Now we go ahead and distribute that negative 1/8 into each term here. So we're looking at 46/8. Watch your signs here, negative 28/8. Alrighty, be kind, be useful, simplify until you can simplify no more. Okay, so let's see, 2 goes into top and bottom of that x value, so it's going to reduce down to 23/4. 4 goes into both of those y values, top and bottom, in that fraction of the y value, looking at negative 7 halves. They are not pretty numbers, but I do believe they are correct. If I wanted to, I could go back and plug them back into the original and go from there. Alrighty, if you have any questions, make sure you contact your teacher, and we'll catch you in the next video.